Thank you very much. I'll try to be brief. My area of interest is soil-transmitted helminths and specifically hookworm. And I'm interested in the molecular approaches we can use, especially in low transmission settings. I'm supervised by Rachel Pulan and Dr. Martin Rono. Hookworm is one of the soil-transmitted helminths, and it's what is of interest to me, and it's of interest to me because it's what is predominant in the study area that I am in. But there are two others, the whipworm and the roundworm. So these worms have similar biology and occur in the same geographic. So they have similar geographic distribution, and therefore they can be controlled together. The group that is most at risk, the school-age children, and it's thought that 1.5 billion are at risk of STH. Luckily, there is a lot of political will and financial willpower from various funders to control this infection, and how it is controlled is through annual deworming of school children in schools, and additionally, the light blue bar, the bars below, STH also benefit from the lymphatic control. Lymphatic filariasis also use albendazole, which is the same drug that we use for albendazole. So the challenge in low transmission setting is an effective diagnosis tool. We currently use the microscopy, and microscopy is dependent on the knowledge that the technicians have. Worms do not give out eggs in a very systematic manner. So today somebody can have eggs in the stool, tomorrow somebody does not have. And if you're using that to say whether the treatment is being effective or not, then it's not a good tool. So there's qPCR, which has been developed for STH, and it's mostly in the lab and has been shown to be quite effective. So my objectives for my postdoc was to evaluate this qPCR first to check whether treatment with albendazole increases the sensitivity of qPCR. This is because albendazole has an effect on the tubulin proteins of the worms, and therefore it is thought that after you treat the person, then you have more material in the stool. So in low transmission settings, then the sensitivity of qPCR will be increased. The second was to determine the sensitivity and the specificity of qPCR using, we compared to Necator cards and using latent variable models. And lastly was to check whether or not we have any resistance to albendazole. So the samples from my study were collected from the Necator project. This was a cluster randomized trial in the coast of Kenya, which was recently published in the Lancet, and for this trial I led the lab component. And so from here I collected stool samples. So we had 3,500 individuals who gave out a 3-day consecutive stool sample, and after the stool sample they were treated with albendazole, and thereafter 1,000 individuals gave a 7-day consecutive stool sample. And from this, I purposely selected 40 individuals, and this was statistically shown to have power to be able to detect whether albendazole could improve the sensitivity of qPCR. So why I chose 40 who had a complete data set. So from these 40 people, with 6 time points of stool, DNA was extracted, and then we did a quantitative multi-parallel PCR. The most common STH is the hookworm. So we did both ancylostoma and Necator americanus, and then data was analyzed. So most of the participants were male. The age distribution was almost homogeneous. We didn't see any ancylostoma duodenale. What we saw was the Necator americanus. So looking at the infection using microscopy, on day 1, only 20 of the 40 were positive. On day 2, we also had 20 of the 40 who were positive. On day 3, we had 70% or 28 individuals were positive for hookworm. So looking at positive on all the 3 days, only 12 individuals were positive. Positive on 2 days, only 9 individuals were positive. And just using 1 day, 14 individuals were positive. So this shows how unreliable microscopy is, and how increasing the number of times you pick a stool sample could increase the sensitivity of microscopy. So using qPCR, we found 35 of the individuals are positive. Then looking at, because quantitative PCR is a quantitative method, you can be able to quantify the amount of DNA, and also catalogs, the microscopy is also a quantitative method, you can be able to count the number of eggs. There was a good correlation in both. So looking at the amount of DNA that was in the stool at each particular day, so at day 0, we knew that they were all positive, and then they were treated, and thereafter we collected a stool sample and checked for the amount of DNA. So there was really no specific trend when you look at individual DNA. So looking at the median, at day 1 when we know that they are positive, there was a lot of DNA, but the DNA went down. So this shows that treatment with albendazole does not increase the sensitivity. So we can't say that when we treat individuals, which was our hypothesis, and then it would help and improve the sensitivity of qPCR. So the next steps from looking at the variability we saw in the microscopy, I have 400 samples more, which I have extracted the DNA, and I've done the PCR, and using this, we'll be able to look at the cost benefit of using multiple samples versus qPCR, because that may be logistically feasible in most of our settings. But the challenge with that would be how possible is it to get a stool sample from a person 3 times? And then I'll now move to the latent class modeling to evaluate the performance of the qPCR. And next we'll be testing the presence of resistance to albendazole, which I have already optimized. The samples that I got from the Necator trial were not adequate to be able to do the albendazole resistance. So I got a new grant, which now I'm able to collect samples for before and after treatment. So giving it the 21-day treatment period given by WHO to look at treatment efficacy. So in terms of engagement, borrowing from what we were talking about on the first day, that in most cases it's not that everything is sort of scheduled. I found myself in Busia. Busia is on the other side of Tororo, where Bungoma, Busia, the other side of Tororo, where we have a lot of malaria, and I was able to meet the public health officers. My PhD study was based on malaria in school children, and we were able to have a discussion on what they can do to be able to, help with the malaria situation in that area, which is almost, 70%. I had an opportunity to organize the NTD Expert Committee workshop, which Professor Wamai is a member. And I've also had an opportunity to be in primary school children, and where we talk to the children about malaria control, especially in these areas where they have nets and they use them to grow vegetables. And I had an opportunity to review the STH guidelines for the Afro region. And the aim of this is to be able to inform policy for the next 2020 strategy for NTDs in the Afro region. And in terms of progress, this was more for Dr. Neba, who was asking about career progression. Before I came to Thrive, I was a teacher in a middle-level college with not much interaction with science, but now I sit in several NTD steering committees in Kenya, and I've also been to WHO. So there are some intangible ways things that we cannot really measure, but being in Thrive has led to me, being a researcher who is sought after. I have collaborations with 4 institutions in various parts of the world, and I have students that I am currently supervising. Thank you.